Hello, welcome to this introduction to clean heat infrastructure with the Midwest Building Decarbonization Coalition. My name is Jacob Serfling. I'm one of the co-directors of the Midwest Building Decarbonization Coalition, and I'm joined by Connor Jansen from Slipstream, a Midwest-based mission-driven nonprofit working on climate solutions for everyone. Just a little bit at the top here about the context of this presentation and the Midwest Building Decarbonization Coalition. This is an adaptation of some presentations and discussion that Connor and I conducted earlier in spring of 2022 with interested stakeholders across the Midwest to really both spread the word about this concept of large-scale clean heat infrastructure or community-scale geothermal heating, and get some feedback on how we can see more of these types of projects across the Midwest. The Midwest Building Decarbonization Coalition started as a project of Fresh Energy, a nonpartisan clean energy nonprofit in Minnesota, with the mission to develop and implement equitable strategies to achieve zero emissions from the Midwestern building sector by 2050. As I said, we've really identified this idea of community scale, clean heat infrastructure, and the policy and technology to support it as a really important tool to meeting those goals. So we've partnered with Slipstream as well as the Blue Green Alliance to spread the word about this concept and try to clear the pathway to see more of these types of projects in the Midwest in the coming years. So I'm going to turn it over to Connor to tell you a little bit more about what we've been up to and educate you on clean heat infrastructure.
Great, thank you so much, Jacob. So the Clean Heat Infrastructure Accelerator has a goal to initiate and accelerate the development of exemplary clean heat infrastructure in the Midwest. And we work on this initiative in three different ways. The first is to encourage broader regional activity and information sharing. We host regular events and roundtables with experts and various different discussion topics. And we help provide resources and convene expertise. Now, the reason for this is that many Midwest states, communities, and institutions have pledged decarbonization goals. And it's imperative that we meet these challenges. And in the Midwest, we really need to focus on solutions that can help heat our buildings without contributing to greenhouse gas emissions. And so on the slide here, we're really showing that 43% of Midwest commercial building energy consumption is made up of both space heating and water heating. And nearly 2/3 of our commercial buildings use combustion as that main source of heat. Now, these proportions go up when we look at residential buildings. 72% of residential energy consumption in the Midwest is for space heating and water heating. And nearly 80% of our residential buildings use combustion as the main source of heat. So what can we do to limit the use of natural gas for heating and hot water? Well, clean heat infrastructure can certainly help with this. This is one of the many tools that we'll have. And it's defined as a service that provides a campus, a community, or group of buildings with a combination of non-combustion heating, cooling, and/or domestic hot water. And several advances have been made in these technologies, especially over the last few years. And so on the right here, you can see a diagram of the Ball State University geothermal distribution system. They're the first university in the nation to decarbonize their heating and cooling system a few years back. Now, shared resources with shared infrastructure helps increase overall opportunity for these types of systems to scale. This common infrastructure can help improve cost effectiveness of electrification. It also has alignment with, and they may result from, building performance standards. So building performance standards are essentially codes or requirements that look at existing buildings' energy performance and set standards or requirements for those existing buildings to be retrofit to meet these higher performing thresholds. Now, these are more prevalent in the Northeast right now, but we want to be prepared here in the Midwest as well. The centralized infrastructure can also help reduce some of the challenges that we see in distributed air source heat pumps. Now, these are a really important technology to aid in our building decarbonization, and these do work pretty well within cold climates as well. But one challenge is that as we may be shifting our buildings to predominantly use air source heat pumps, our overall peak load demand on our grid will not only switch from the middle of the summer to, let's say, a cold winter morning when we need to heat up our buildings, but it will also likely significantly increase. So these types of systems help keep that increase of peak load down. They can also improve local air quality, especially in really dense urban areas where you have a lot of buildings using different sources of fuel, burning that fuel for heating, and creating localized areas or pockets of poor outdoor air quality. So switching over to more of a distributed system that does not directly burn fossil fuels will help increase that overall impact on air quality. Lastly, we have described here that district or community-based heating and cooling systems also provide an opportunity for equitable job creation and revenue generation. And district systems have been around now for nearly 150 years. The early and even current examples are especially prevalent in European countries. And the advancement from these first coal-fired steam systems that started back in the 1800s started to combine heat and power together for production, helping to increase overall efficiency. And these second generation systems really created much of the infrastructure we see here in the United States. They were built between 1930 and 1980. And while these aging systems have been advancing the last 40 years or so by adding different streams of waste heat, they still use high water temperatures and large scale equipment, and they aren't very flexible. But current advancements in technologies have opened the door for smaller, more distributed systems that are connected to a central loop and operate at a lower working temperature. So here's a diagram of these new systems or these fifth generation district heating and cooling systems. So they are more flexible. They use a water loop that's much closer to ambient temperatures and are usually coupled with a ground heat exchange. Small distributed heat pumps are then connected to that loop, allowing for simultaneous heating and cooling of our individual buildings or spaces. So allow for future expansion and different sources of energy and storage. One really interesting example of this type of system, which we've dubbed Clean Heat on Main Street, is in West Union, Iowa, which is a small town of about 2,500 people. And they had a federally funded $10.2 million initiative to green up and improve their infrastructure, replacing streets, water mains, and sewer lines. And they use this opportunity to also add in a geothermal loop for about $2.3 million, which significantly saved costs if they were to just do that system alone and have to do all that work tearing up streets and things like that. And so they installed 132 wells, which provides about 264 tons of heating and cooling capacity. And that system serves 11 entities right now. The city-owned system is leased to West Union District Energy LLC, which is made up of the system users, and each pay in $14 a month per ton of capacity that they need. And what we've seen so far from all of the case studies on this, they've shown both an energy and utility cost savings over the traditional gas heated systems that these buildings once had. Now, there are several different energy sources for clean heat infrastructure. The most prevalent is really geothermal or ground source heat pumps. And there are thousands of applications of these systems in the Midwest today. Now, these are more standalone individual building with its own individual set of geothermal wells. But with this concept, we're essentially taking that same system and expanding and having a centralized set of geothermal wells serving multiple buildings. And we know that these standalone systems work really well. I feel like every 6 months or so, I read an article talking about a new net zero school has gone up. And more often than not, that net zero school is utilizing geothermal technologies. Another potential avenue would be large-scale air source heat pumps. And this could help provide a possible one-for-one conversion for existing boiler systems. So replace that old gas-fired boiler. New technologies are emerging right now. A lot of the growth in this market has been led by European countries, but we are starting to see some of these technologies come to the US, which is really exciting. And then lastly to point out is carbon-based dispatch of combined heat power systems. Now, these systems would not be fully decarbonized on day one, but instead, these existing district systems would start to utilize different types of storage, be it battery storage and renewable energy, as ways to start to bridge to a more decarbonized central plant. When it comes to system applications, community geothermal systems can work really well for both residential developments, and these could be single-family homes, over to multifamily or mixed-use developments, which you see here on the right with River Heath, which uses GeoExchange with the Fox River in Appleton, Wisconsin. Or community geothermal could work for highly dense downtown corridors. It's important to have enough capacity within these systems, the ability to put the infrastructure in, and some level of diversification of loads. Another application would be to convert existing plants over. So we've seen this on the university side of things and in new medical and commercial campuses, essentially moving from combustion-based central campuses over to geothermal type systems. You could also look at new large-scale district clean energy projects. Some newer district projects have gone up over the years, usually combined heat and power, some of them perhaps using biomass as one of the many different fuel sources. Typically, these would work best in dense urban areas with lots of load diversity. And then lastly is the utilization of waste heat. So things like data centers or industrial processes. There's some really cool pilots happening right now in the UK around data center waste heat recovery. When it comes to college decarbonization and district geothermal systems, the list of projects here is growing. A really good example is Carleton College in Northfield, Minnesota. And to just kind of set the stage of the time frame here, back in 2011, they set a goal to be carbon-free by 2050. And they really used a phased approach to completely transition their central plant off steam to a lower temperature 120-degree heating hot water system, which geothermal system could work with. And in fall of 2021, they completed this project. And that geothermal system will be serving 70% of their annual heating and cooling needs. They implemented a new high-efficiency gas-fired boiler to address some of that peak heating demand. And then they're going to keep their existing chiller to address the peak cooling demand. So this is a really cost-effective approach to work towards decarbonizing their campus. And overall, they're expecting to save 29% on operating costs and about 15% on CO2 emissions. And that number is only going to grow as the grid gets cleaner. Outside of energy efficiency and carbon improvements are labor benefits. And skilled labor is going to be needed to operate district systems, providing career opportunities and advancement for several people within this industry. And the centralized systems are going to increase the need for full-time operators in lieu of the distributed technicians out there that may be servicing air source heat pumps or something like that. It's also important to point out that there's definitely transferable skills from the gas labor workforce, and utility pilots, which we'll talk about a little bit more in a couple slides, are testing out different clean district heating pilots as a service. On the right here, you see an image from the Gunderson Health central plant, and they were able to become more energy independent with the use of both renewable and biomass combined heat and power plant. And what's important to point out here is that with the installation of the system, they were able to keep about $600,000 in annual energy expense within the local community, helping to create jobs to not only just run that system, but also for the local forest products industry. It's a really good story there and partially funded by the USDA. Equity improvement is another important consideration. And these systems really have the ability to help reduce housing energy burden by being very efficient and providing opportunity for sharing of different heat and cooling streams across the campus. They provide a pathway as well for individuals to decarbonize from low and moderate income households. So they can connect to a clean district plant, but it would probably be pretty challenging for them to cover their own full cost of an individual geothermal system. There's also really important ties with these types of systems to public housing and other ownership and other owner operators looking to reduce operating expenses through upfront investment. With that, I'll pass things back over to Jacob.
Great, thanks Connor for that overview. We also wanted to touch a little bit on some of the questions we heard from potential stakeholders about what business models for these types of systems can look like and what types of funding opportunities are currently out there or might be on the horizon. So in terms of ownership models, the most prevalent for these types of community scale clean heat infrastructure systems is some sort of public-private partnership, like we saw in West Union, where there's that West Union Heating LLC that operates the system. And in general, a single ownership model is the most prevalent that we've seen, although there are examples of systems with more of a multiple or community ownership model in existence as well. We know that there are federal grants available or in the works through some of the legislation that has been passed in the past couple of years. The IIJA, or the Infrastructure Investment and Jobs Act, created some competitive grants through DOE specifically for advancing community geothermal systems. There are aspects of the IRA that could apply to these types of systems as well, whether that be expansion of tax credits for geothermal heating systems, or changes in how other types of financing available through DOE could become available, although it's still a little bit in progress how some of that will shake out. We're also seeing more expansion of utility pilot programs. So one example of that is the Corn Belt Energy GeoSense program that offered financing for geothermal heating systems through the utility. We've also seen more gas utility pilots, especially in Minnesota, after the passage of the Natural Gas Innovation Act in the works, that would look at a utility-owned model of these types of community-scale clean heat projects. And then just the opportunity to look at existing district energy building models as their equipment ages out. Many cities and college campuses, as we discussed previously, already have some sort of district model in place and a business model to support it. So looking at opportunities for converting that to geothermal as their equipment ages out. In terms of key challenges, this is really hitting on that discussion that we had with stakeholders back in spring of 2022, and where they identified their key challenges at the moment. First was just where to start after that initial interest in this type of project was established. And really the answer to that is, feasibility studies in taking advantage of technical resources as they come out, identifying whether your building or site is even applicable for doing a geothermal type system, whether equipment currently serving buildings is going to work with that type of system or not, and bringing an engineer on board to do that type of feasibility study. Understanding some of those financing pathways that we just discussed. And then the idea of just staging these existing infrastructure upgrades. These are long-term projects that affect multiple buildings, and they should factor into a long-term master plan for a campus or an area of development in a city to make sure that you're appropriately staging any existing infrastructure upgrades to accommodate it. We have seen a rise of utility programs in support of these types of infrastructure projects. The first big example was with National Grid in New York. So they deployed their pilot back in 2016 for 10 houses. And then in 2020, an additional $12.9 million proposed to deploy an additional 2,600 tons of shared geothermal ground loops that would serve the equivalent of 650 single-family homes. So really ramping up from that first initial pilot that they did in New York. In the New England area with Eversource Energy, we saw Massachusetts pass the New England Climate Bill that allowed for network geothermal projects, pilot projects to start with Eversource as a possible solution to their aging gas infrastructure instead of continuing to expand that fossil fuel system. So They are in the process of selecting sites for their initial 3-year pilot that'll occur in Framingham, Massachusetts, serving 100 homes and commercial customers. NYSERDA, the New York State program, also kicked off a community geothermal project in 2021. That first round of projects included 23 projects with a total of $4 million in funding. And we also continue to hear indications that Midwest utilities, notably Xcel Energy in Minnesota, are investigating community geothermal as a service business model. As I said, they passed that Natural Gas Innovation Act in Minnesota, which is kind of driving that interest there. So if you're interested after hearing this introductory content, we really encourage folks to continue to engage with Midwest BDC and Slipstream through this accelerator. We're working to facilitate information sharing, form working groups as we see opportunities to work with legislatures or utility commissions to clear a pathway for more utilities or municipalities to pursue these types of projects, connect folks with what they need for that feasibility or project planning stage, and get more of these projects in the ground. So we hope that you'll continue to engage with us and resources that we're trying to put together to assist folks here in the Midwest. And then this is, as I said, just one of many technologies and policies that the Midwest Building Decarbonization Coalition as a whole is trying to promote across the region to achieve that mission of no fossil fuels in the Midwest building sector by 2050. We have a monthly meeting with all coalition members, as well as numerous other working groups and trainings that we do to tackle other building decarbonization topics. Really encourage folks to check out the website at midwestdecarb.org or follow us on social media or email me at serfling@freshenergy.org to learn more about what the rest of the coalition is up to.